Hello everyone, hope you had great fun learning from home. Today we are going to learn about chemical bonding. There are two types of chemical bonding, the ionic bond, or rather the ionic bonding, and the covalent bonding. The ionic bond is a very strong electrostatic bond formed between a metal ion and a non-metal ion. A covalent bond is also a strong bond between two non-metal atoms. The metal and non-metal ionic bond involves one party giving up the electron and the other party taking up the electron. The covalent bond involves the sharing of electrons between the two non-metal atoms. We will explore further later. Hi, let us now look at ionic bonding. Suppose we have a sodium atom. Sodium has a proton number of 11, so the electronic structure is 2, 8, 1. So the sodium electronic structure is not noble, is not complete. In order for the sodium atom to become complete, it must lose one electron to become 2, 8. In so doing, the sodium atom becomes the sodium ion. Originally, the sodium atom has 11 protons and 11 electrons, and overall it is neutral or zero charge. By having become a sodium ion, it still has 11 protons, but it now has only 10 electrons, and so overall it has a +1 charge, and that's why the sodium ion has a +1 charge. The sodium ion is now stable or noble. However, another party must be willing to receive the electron that the sodium atom gives up. Who would be that willing party? Now come along a chlorine atom. The chlorine atom has a proton number of 17. 17 has an electronic structure of 2, 8, 7. So the chlorine atom is also not noble state and not complete and not stable. To become stable, to become noble, the chlorine atom needs one more electron. Okay, so the chlorine atom needs one more electron so that it can achieve the noble state of 2, 8, 8. Okay, to do so, the chlorine atom receives an electron to become a chloride ion. Let's count the number of protons and electrons before and after that transfer. At first, the chlorine atom has 17 protons and 17 electrons, and overall it is neutral. Having received an extra electron, the chloride ion still has 17 protons, but it now has 18 electrons. As a result, the overall charge is now -1. That's why chloride ion carries a negative charge. So when a sodium atom and a chlorine atom comes together, they can form an ionic bond. The sodium will be able to give away an electron, while the chlorine atom will receive the electron, and in so doing, they both become ions, and since opposite charges attract, the positively charged sodium ion will be strongly attracted to the negatively charged chloride ion. And what we get in the end is an Na plus ion ionically combined with a chloride ion to form compound sodium chloride. This is the fundamental basis of ionic bonding. As we learned earlier, the sodium atom will give up one electron to become a sodium ion, while the chlorine atom will receive that electron to become a chloride ion. We need to draw the outer shell electrons to depict the ion. In the case of sodium, the proton number is 11 and the electron structure is 281. But when sodium becomes an ion and loses an electron, the sodium ion now has an electronic structure of 2,8. In the case of chlorine, it has a proton number of 17. The original electron structure is 287. By receiving an extra electron, the chloride ion now has an electronic structure of 288. In the exam, most of the time we are required to draw only the outer shell electrons. So in the case of the sodium ion, we will draw just 8 electrons in the outer shell. 1, 2, 3, 4, 5, 6, 7, and 8. The square bracket to symbolize that it is an ion and the correct charge. In the case of the chloride ion, again, we draw only the outermost shell electrons. Now, we draw a different set of electrons to distinguish it from the sodium electrons. So originally, chlorine has 7 electrons of its own, but it received 1 electron from sodium. That electron will be a cross, and then we add in the charge of the chloride, so this will be the required diagram for the ionic compound sodium chloride. Hi, let's look at the second example of ionic bonding. Suppose we have a magnesium atom. The magnesium atom's proton number is 12, and 12 gives you the electronic structure of 2, 8, 2. In order to become noble state or complete state, magnesium has to lose 2 electrons to become the noble state of 2, 8. So originally, magnesium has 12 protons and 12 electrons, and so overall it is neutral, it has no charge. But when the magnesium loses 2 electrons, It still has 12 protons, but it now only has 10 electrons. So overall, it now has a 2+ charge. Let's say on the other side, we have fluorine. Fluorine has an atomic number of 9, which gives you the electronic structure of 2,7. So fluorine is also not noble, not stable. To become noble, to become stable, fluorine has to gain one more electron. It has to gain one more electron to become the noble state of 2,8 as well. Let's see. Originally, fluorine has 9 protons and 9 electrons. So overall, it has no charge. But when fluorine becomes an ion, it still has 9 protons, but now it has 10 electrons. Overall, it has 1 extra electron, so it has a charge of -1 now. Now, how is a magnesium ion and a fluoride ion going to come together to form a compound? Now remember, the magnesium atom has to lose 2 electrons in order to become stable. On the other hand, the fluorine atom needs to receive only 1 electron to become a fluoride ion. The number of electrons given must balance the number of electrons received. Otherwise, there will be either insufficient electrons or they're on one party, or excess electrons for the other party. To do that, we need to multiply the second equation throughout by 2. So now the magnesium can give 2 electrons and the fluorine can receive the 2 electrons. But notice it's not 1 fluorine atom, it's 2 fluorine atoms. So you need 2 fluorine atoms to receive 2 electrons from 1 magnesium atom. So what you end up with is a magnesium ion chemically joined to 2 fluoride ions. Continuing with our example, the magnesium atom loses 2 electrons to become a magnesium 2+ ion. Magnesium originally has electronic structure of 282. When it loses 2 electrons, the electronic structure becomes 2,8. On the other hand, the fluorine atom receives an electron to become a fluoride ion. Fluorine atom originally has an electronic structure of 2,7. By receiving an extra electron, it becomes 2,8. So the electronic structures of Mg2+ and F- are exactly the same. Now let's draw the electronic structure of the magnesium fluoride compound. Before that, we need to make sure that the electrons given by the magnesium must balance the electrons received by the fluorine. Now currently they are not balanced. Magnesium can't give 2 electrons if fluorine would only receive 1 electron. To do so, to balance both sides, we need to multiply the second equation by 2 throughout. Now in doing so, we now have magnesium side giving 2 electrons and the fluorine side receiving 2 electrons. The electrons are now balanced. And it's balanced because we are now having one magnesium atom giving electrons to 2 fluorine atoms. So now let us draw the full electronic structure of the magnesium fluoride compound. First, the magnesium ion has 2 electrons in its inner shell and 8 electrons in the outermost shell. And we draw the square bracket to symbolize that it is an ion, and we write down the correct charge. Now in the case of the fluorine or the fluoride ion, there are actually 2 ions, so we must put a capital 2 there to symbolize that there are 2 fluoride ions. We've got to make sure that the charge is correct. So now the fluoride ion also has 2 electrons in the inner shell and 8 electrons in the outer shell. But bear in mind, we have to use a different symbol for the electrons. So for the fluoride ion, it originally has 2,7 electrons of its own, but it received 1 electron from the magnesium, and that's why there's 1 cross out of the 10 electrons in the fluoride ion. So this will be the full electronic structure of magnesium fluoride. As a final example of ionic bonding, let's look at the bonding between calcium and nitrogen. Calcium has a proton number of 20. So the electronic structure is 2, 8, 8, 2. So calcium can become noble gas configuration by losing 2 electrons to become 2, 8, 8. So originally calcium has 20 protons and 20 electrons and overall 0 charge. But what about the calcium ion? It still has 20 protons, but because it lost 2 electrons, it now has 18 electrons only. Overall, it has a charge of 2+. So that's why the calcium ion has a charge of 2+. Now what about nitrogen? Nitrogen has a proton number of 7 and an electronic structure of 2, 5. Now in order to achieve the noble gas configuration, it needs 3 more electrons, and doing so it will become 2, 8 electronic configuration. So nitrogen originally has 7 protons and 7 electrons and overall 0 charge. But the nitrogen ion still has 7 protons, but now it has 10 electrons, so overall it has a 3- charge. So nitrogen ion has a charge of 3-. Earlier we saw the ionic bond between calcium and nitrogen. The calcium atom lost 2 electrons to become a calcium 2+ ion, while the nitrogen atom received 3 electrons to become a nitrogen 3- iron. Again, we must make sure the electrons are balanced. Calcium can't give 2 electrons when nitrogen needs 3 electrons. So we need to perform a lowest common multiple to make sure that the number of electrons given is equal to the number of electrons received. So 2 times 3 is equals to 6. Hence, we need to multiply the equation on the left hand side by 3, and we need to multiply the equation on the right hand side by 2. In so doing, we have now balanced the electrons. So the calcium gives 6 electrons, while the nitrogen receives 6 electrons as well. So effectively what we have is 3 calcium atoms combining with 2 nitrogen atoms to give you 3 calcium ions and 2 nitrogen ions. So the final chemical formula is Ca3N2. How do we draw the electronic structure of Ca3N2, calcium nitride? Well, obviously, we are going to have 3 calcium ions. And we are going to have 2 nitride ions. Recap: when calcium became a calcium 2 plus ion, it lost 2 electrons. So from an electronic structure of 2882, it now has an electronic structure of 288. Similarly, when the nitrogen received 3 electrons to become a nitride ion, the electronic configuration went from 2,5 to 2,8. Now in the exam, you might be asked to draw the full electronic structure, but most of the time you are only asked to draw only the outer shell electrons. In the case of the calcium ion, there are 8 outer shell electrons, so we draw 8 electrons in the outer shell of calcium. Now in the case of the nitrogen, we must be careful with the symbols that we use to draw the electrons. The electrons that the nitrogen atom possess at the start, we use a different symbol. Nitrogen originally had 5 electrons of its own, so we draw these 5 with a different symbol. Having done that, the nitrogen atom will now receive 3 more electrons from the calcium. This time round, we draw the crosses to denote that they came from the calcium atom, and this will be the final answer.